So the time has finally come. Now we can get into the nice juicy stuff of trigonometric differentiation. So basically I'm going to be working through the derivatives of sine, cos, and tangent. So let's start off with sine. So the derivative of sine x. What is that? Well, we can use the difference quotient to help us understand this. Right? So in every x value, we'll be putting the x plus h first, then subtracting it by the normal, what it is normally, all divided by h, right? We continue to write the limit of h approaching 0. So we can just use the addition formula for sine bracket x plus h. So this would just be sine x cos h plus sine h multiplied by cos x minus sine x all over h, right? Now the limit of h approaching 0. Now let's see what we can do here. Well, we could sort of just split up this whole thing. We could sort of do this. We can take sine h over cos x, and we could take this and this as well. So not including the pink. And now the reason I'm doing this is because I want to use the previous two limits I had shown in the last two videos, because those are going to help me figure out what is the derivative of sine x. So writing the pink here, this would be sine h cos x all over h plus, now writing the blue in here, this would be sine x cos h minus sine x all over h, right? I'm just splitting up the fraction. Nothing fancy here. Now taking the limit of h approaching 0. For this one, I can say, because I want it in terms of one of the limits, and one of the limits I've already done is sine x over x. Now we just have sine h over h, so we can just sort of take cos x away from that fraction. We're still multiplying it. Plus, another limit we learned, actually, is, 1 minus cos x over x, but we're obviously dealing with h's now. So we should end up in a situation where we get 1 minus cos h over h. And the way we can do that is we can factor out a sine x, right? Which would give us cos h minus 1 over h, right? But we want it the other way. We want it 1 minus cos h, so we take a negative. We take a negative sine x. So then that will give us 1 minus cos h over h. Now hopefully you see where I'm going here. Now I'm just going to do limit property and add, put the limit for everything. So the limit of h approaching 0 of sine h over h multiplying by this cos x here, subtracting the limit of h approaching 0 of 1 minus cos h over h, right? And then multiplying with sine x. I just put the negative of the sine x over here. So now we just evaluate. So the limit of h approaching 0 of sine h over h is just 1, right? And there's nothing to be done here with this cos x, so this is just 1 multiplied by cos x, which is, well, just cos x. Subtracting the limit of 1 minus cos h over h, well, that's just 0 from the last video, and again, nothing's happening with the sine x because there's no h value. Multiplying by sine x, and 0 multiplied by anything is just nothing, right? This just becomes 0, and therefore, drum roll, well, I've already spoiled it before I said drum roll, but the derivative of sine x is actually cos x. Who would have thunk? try, going on Desmos on your graphing calculator and just put in, f of x equal to sine x, and then put f apostrophe of that, and they'll show you it'll be cosx. And you can verify that by writing a second function, y equals cosx, and it'll show that the derivative of sine x is actually cosx, and you can sort of intuitively see that. So let's do another one. Let's now say I asked you for the derivative of cosx. Pause the video and see if you can actually do this one. So same idea, we're just going to use the difference quotient, the limit of h approaching 0 of cos x plus h minus cos x all over h, right? Now we're just going to use one of the addition formulas we learned in our previous course, right? So this would just be cos x, cos h, right? This guy over here. Cos x, cos h minus sine x, sine h, subtracting cos x all over h. So we would get the limit of h approaching 0. Now I want to end up in a situation where I can have the two limits I talked about in the previous video because I know the value of those. So I see that maybe for the cos, to end up in a situation where I get 1 minus cos h, I can factor out cos x from here and here, right? So this, and you know what, I'll do it in this blue. So this would give me, if I factor out a cos x, this would give me cos h minus 1 over h plus, now all I'm left with, and actually this would be a minus, this would be minus sine x over sine h. Now the last one I skipped the step, but I'm showing it here. So in order to get 1 minus cos h, we can just factor out a negative. So this would be negative cos x, 1 minus cos h, all over h, right? Subtracting, I can just take out the sine x here to show it. This would be sine h over h, right? Now taking the limit of everything, so the limit h approaching 0 of negative cos x, oh, forgot to do it in the blue, cos x of 1 minus cos h, or I should write it like this. There we go. 1 minus cos h over h, multiplying by the negative cos x, subtracting the sine x, or I should write the limit of h approaching 0 of sine h over h, multiplying by the sine x. I just took the negative from the sine x and placed it here. So the limit of this guy, well, we know that's 0, so this just becomes 0 multiplied by this, right? Because there's this dot here, the multiplication sign, so this whole thing just becomes 0. Then we're just left with this negative limit. So then the negative, or I can just say the limit of h approaching 0 of sine h over h, well, that's just 1, right? From what we know. Right, so there's a negative, and then we have negative 1 here, and then a sine x, right? Because that's multiplying that. So therefore, the derivative of cos x is negative sine x. Pretty interesting stuff, right? Maybe I'm the only one who finds it interesting. Hopefully that made sense. Let's do one more. How could we forget tangent? So the derivative of tan x. Now there's a hard way to do it. I could totally take the difference quotient, I believe, and I can torture you and me, and this video will be very long if it isn't long enough already. What I'm actually going to do is I'm just going to use the quotient rule. So I'm going to just write the derivative of this as sine x over cos x, right? Because that's what tangent is. And now you see a window of opportunity to use the quotient rule. So don't, I mean, if you want to use the difference quotient and prove it to yourself, go ahead. I'm sure it'll work, but I've not done it because it just looks like too much work. But I'll just use the quotient rule. If you forgot the quotient rule, I'll write it out for you here on the side. Right, if we're taking the derivative of this, that would just be f prime x gx subtract f of x g prime x all over g of x being squared, right? So knowing that, we can take the derivative of sine x, multiply it, so that looks like a 1, multiplied by cos x, subtract sine x, taking the derivative of cos x all over cos squared x, right? Now the derivative of sine x, what was it? Well, we can just scroll up and look here. Well, oops. The derivative of sine x was just cos x. So we plug that in. So cos x, right? And now we see a cos x multiplying another cos x. So this becomes cos squared x, right? Minus. Now, oh, I forgot to write that. Apologies. But the derivative of cos x, what's that? We just worked it out. That's negative sine x. Now, negative sine x, right? Actually, I'll just write it. Negative sine x. Well, negative sine squared x, right? Right, because the sine x is multiplying the derivative of that all over cos squared x. Right? We see a negative and negative here, so they both become positive, right? Now, that would just be cos squared x plus sine squared x over cos squared x. We can use, hopefully I'm recalling the name right, but I think it's the Pythagorean identity, right? Where it's cos squared x plus sine squared x. If it's not the Pythagorean identity, it's some identity, that's for sure. I'm sure you know this from your previous math course, right? So that just gives you 1. So we can just substitute that in to simplify this, and we get 1 over cos squared x. We can also say just secant squared x, but we'll just leave it at that because it's just helpful. But that is the derivative of tangent x. So pretty nifty stuff. Hopefully, this was helpful. I wasn't too fast or too slow. Try to find a balance. Yeah. I just think it's important to show the derivatives of these so you understand. I'm not sure if teachers do this. If they do, great. This is nice, helpful. But let me know in the comments if this video was helpful or not. And yeah, see you in the next one.